Hello everyone. Here we shall solve some previous year KCET questions. The chapter on any doubts if you have, please write us in the comment section. Any steps if you are unable to understand, you can also write that in the comment section. In any other chapter, if you feel more difficulty, please mention the name of that chapter also in the comment section. We shall give more clarity on it, solve more and more questions on. Also some important homework questions on previous year KCET exam in the Sapience education. So please install our it has been. Here we shall start from the very first question onwards. It's told that value of the alternating MF circuit. So we know that E square that is equal to VR square plus VC minus VL square. So therefore E will be equal to square root of VR square, is the voltage across the resistance of VR plus VC minus VL whole square. This will be square root of 80 square 100 minus 40. This is over 80 square plus 60 is equal to 100. So the alternating EMF is A is the correct answer. With a current of 5 ampere is flowing at 220 volts in the primary coil of a transformer. This is the primary coil, this is a secondary coil. So the current to the primary coil, that is, and voltage is 220 volts. 20 volts. If the voltage produced in the secondary coil, output voltage, that is equal to, I can say Vs, voltage across secondary coil, that is 50% of power is lost. Current in the secondary will be. It means that 50% of the electrical power that will be equal to, so 50% is lost means 50% is remaining. 50% of the electrical power, that is equal to the power output across the secondary coil. Power output across the secondary. Therefore, 50% of the input power is the power across the primary. Is IP into EP, the voltage across presence. That is equal to Vs into the current in the secondary coil that you have to find. It means that 50% is half of IP 5 ampere into 220 volt, that is equal to Vs, that is 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 5 by 2 into 220 by 22 ones are 22 10 is a 10. Is 1 by 4 ampere, that is equal to 0.25. Option A is the correct answer. Then in the question number 3 is told, for a series LCR circuit at resonance, a statement which is not true is. Wattless current 0. Power factor is 0. Peak energy stored by capacitor equal to peak energy stored by inductor. Average power equal to apparent power. Which of these is not true? At resonance, we know that resonance XL is equal to XC, means the inductive reactance equal to capacitive reactance. Omega L, that is equal to 1 by omega C. From here we can find omega, that is 1 by root over H. So this is the angular frequency of the at resonance. So XL is equal to XC means the power factor that is cos phi so the power factor is R by Z. At resonance, Z is equal to R. The net impedance, that is equal to the resistance. So cos phi is equal to 1. So the power factor is not 0. And the wattless current is IRMS into sin phi. So that would be 0. Since cos phi is 1, so phi is equal to 0 degree. So sin phi will be 0. So IRMS sin phi is 0. Peak energy stored by capacitor, that is half C V naught square, it is equal to peak energy stored by inductor. So it's half Li square, half Li naught square. The average power, that is equal to apparent power. So therefore the power factor is not 0. So option B is the wrong statement. So it's the correct answer. Since it is asked which statement is not. Statement B is not. Question number 4, it is told an electric heater rated 220 volt and 550 watt. So that is connected to the AC mains. The current drawn by it is on. You know that power equal to voltage into current. Therefore, the current will be power by the voltage. It is 550 watt divided by 220 volt. So this much ampere. So that is equal to 7 to the 11.5. So 2.5. Option B is the correct. Then question number 5, it is told a resistor R and a capacitor are connected in series with an AC source. If the potential drop across the capacitor, it is 5 volt. Across the resistor, the potential drop is 12 volt. Applied voltage is out. So we know that the applied voltage will be V, that is equal to square root of VR square plus VC minus VL whole square. But here there is no inductor, so VL will be 0. Therefore, simply it will be VR square plus VC square. It is square root of 12 square plus 5 square. So that is equal to 144 plus 25, that is 169, so that is 13. That is 13 volt. The applied voltage. A is the correct answer. It is told an ideal choke contains a current of 8 ampere connected to an AC supply. An ideal choke means it is an ideal inductor which is having 0 resistance. An ideal inductor having 0 resistance. It is connected to an AC supply which is 100 volts and 50 hertz. The current drawn by it, I, that will be equal to RMS by XL. Since here Z is equal to XL, if there is no resistor and there is no positive, it will be VRMS, that is 100 volt divided by XL. XL is equal to omega L. Omega is 2 pi into nu, 2 pi into 50 hertz. That is equal to 100 pi. 100 pi radian per second. Omega L, 100 pi L. Here it is told pure resistor draws a current 10 ampere and connected to the same source, 100 volt and 50 volt. The ideal choke and the resistor are now connected in series. Then connected to the to a new AC source which is 150 volt and 40 volts. Current in the circuit becomes how much? So from here we can find out L. It is equal to 100 pi to IRMS. IRMS is 8. 100 will cancel, so it is 1 by 8. It is equal to 1 by 8 pi, and the resistance that will be equal to VRMS by IRMS. Volt by 10, that is 10 ohm. Here we have to find the current in the circuit. Current in the circuit, in the new circuit, that is Vrms by Z, where Z is equal to the root of R square plus XL square. If there is no capacitor, only inductance is there. We have to use only inductive reactor. So Vrms. So this is 150 volt by square root of 12, that is 10 square plus XL. So XL will be omega L. It is 100 pi omega into 1 by 8 pi. So that will be 4 to the 8, 4 to the 5 to 100. It is 25 by 2. It will be also 25 by 2. IRMS, that will come as 150 divided by, because this is 200. Sorry, this is 400. This is 625 by 4. That 2 will go up. 150 into 2 by square root of 1025. So here actually XL is omega L. Sorry. It is wrong. So here also we have to use the new omega, new value of the omega, that is new value of the omega, that is omega dash, that is 2 pi into u dash, 2 pi into 40, is 80 pi. 80 pi. So new value of XL, that is omega dash into L. Omega dash is 80 pi into 1 by 8 pi. So that is equal to 10 ohm. This is square root of 10 square plus 10 square. This is 150 by 10 root 2. So this is 15 by root 2 ampere. So option A is the correct answer. Question number 7, it is told that the series resonant RLC circuit, the voltage across R is 100 volt. The series resonant RLC circuit. So resonant means omega is equal to 1 by root LC. It means the net impedance Z is equal to R. The voltage across the resistance is 100 volt. R is 1000 ohm. Capacitance R, resistance is 1000 ohm. Capacitor is 2 microfarad. This is the AC source. So we have to find the voltage across R, VR, that is 100 volt. Angular frequency of the AC, that is 200 radian per second. You have to find the potential difference across the inductance curve. This we have to find VL. VL we have to find. VC. voltage across R is 100 volt. So the net voltage that will be equal to square root of VR square plus VL minus VC whole square. VL that is equal to VC since it is a resonant circuit. VC is resonant circuit. IRMS equal to VRMS by R. Since here Z is equal to R. VRMS 100 volt divided by resistance 1000. VL is equal to VC. So I can say that the net input voltage that is also equal to VR. This will be 0.1 ampere. Now the potential difference across the inductor VL that will be equal to IRMS into XL. It will be IRMS that is 0.1 ampere into XL. .1 ampere to XL. This is omega into L. That is also same as VC is equal to IRMS into XC. Therefore, VL equal to VC that is equal to IRMS into XC. So IRMS is 0.1 ampere into XC is 1 by omega C. So equal to 0.1 by omega that is 200 percent into 2 microfarads into 10 power minus 6. This much volt. So VL that will be equal to VC that is equal to 0.1 divided by 400 to 10 power minus 6. So this will be 10 power 6. It's 10 power 5 by 400. This will be 1000 200 by 400. 0 will cancel out. 2 to the 4, 2 5 the 10, 2.5. So 2.5 into 100 that is 250. Option C is the correct answer. Question number 8 is told a capacitor and an inductance coil are connected in separate AC circuits with a bulb glowing in both the circuits. The bulb glows more brightly when an iron rod is introduced into the inductance coil. When iron rod is introduced, then the inductance L will increase. Means that XL will increase. When XL will increase, then the current will decrease. RMS is RMS by XL. So current is less, so the bulb less. Number of turns in the inductance coil, number of turns is increased, then also the inductance will increase. So inductance increases, then XL inductive reactance will increase. So then current. So the bulb will glow less brightly. The separation in between the plates of the capacitor is, so we know that the capacitance is given as epsilon naught A by D. So when the separation in between the plates, that is D, the capacitance will decrease. When the distance of separation increases, then the capacitance will decrease. So when the capacitance will decrease, then Xc, that is capacitive reactance, which is 1 by omega c, that will increase. So the capacitive reactance will increase means the current will decrease and the bulb will glow less bright. And dielectric is introduced into the gap between the capacitive plates. So then, when a dielectric is introduced between the gap, then the capacitance will come as K epsilon naught A by D, where K is the dielectric constant of that dielectric. So when the dielectric is introduced, then the capacitance will increase. Capacitance increases, then the capacitive reactance will decrease. So when capacitive reactance will decrease, then the current will increase. This is why the current IRMS case of a capacitive circuit, that will be equal to VRMS by X. When Xc decreases, then the IRMS increases. So when the current increases, then only the bulb will glow more. It means that option D is the correct one. Then question number 9, it is told C circuit V and I are given by 150 sine 150t and I is equal to 150 sine 150t plus 5 by 3. The power dissipated in the circuit, the average power that is dissipated, that will be equal to VRMS into IRMS cos phi. The cos phi is the angle by which the current leads the voltage. So VRMS, that will be equal to 150 by root 2. IRMS also, that will be equal to 150 by pi, that is equal to pi by 3. Since it is the angle by which the current function is leading the voltage function by a phase angle of pi. It will be VRMS, that is 150 by root 2 into VRMS 150 by cos phi, that is cos pi by 3. So this will be 150 into 150 25 0 divided by 2 into cos pi by 3 is half. It will be 22500 divided by 4 is equal to 4 5s are 20, 4 6 are 24, then 4 2 are 8, 4 5 are 20. So it is 5625. 5625 watt. So this is the average power that is dissipated in Question number 10, it is told the series NCR circuit shown. The impedance is how much? Right? The series LCR circuit, the impedance is how much? So the impedance is equal to R square plus XL minus XC whole square. So here Z is the net impedance. Here R is 300 ohm. XL, that is equal to that is equal to 1 by omega c. And here the capacitance is given as 20 micro. So this is 20 into 10 power minus 6. So this is 20 into 10 power minus 6 farad. Therefore XC, that is equal to, and omega, that is equal to 2 pi into nu. That is 2 pi into nu frequency, that is given as 50 by pi hertz. It's 100 radian per second. So this is the angular frequency of AC voltage source. So XC is 1 by omega c, equal to 1 by 100 into 10 into the 10 power this much ohm. This will be equal to 10 power 6. So this is 1000 into 1000 divided by 2000. 0 will cancel, so 500 ohm. Similarly, XL is omega L, which is called inductive reactance. Therefore, XL, that will be equal to omega. It is omega into L. XL is 100 into L. Here L is 1 Henry. So that is 100. L omega into L, so this is 100 ohm. Therefore the net impedance Z, that is equal to square root of R square. R square, that is 300 square plus XC minus XL whole square. So 500 minus 100 whole square. This will be equal to 300 square root of 300 square plus 400 square. This will be equal to obviously 500. And D is the correct answer. Then question number 11, it is told a transformer works on the principle of self-induction, mutual induction, electrical inertia, magnetic effect of the electric current. So a transformer works on the principle of mutual induction. There is a primary coil whose magnetic flux is linked with that of the secondary coil. So it means that it works under the principle of mutual induction. Transformer works on the principle of mutual induction with C. C is the correct answer. Then question number 12, it is told an ideal resistance R, ideal inductance L, ideal capacitance C, and AC voltmeters V1, V2, V3, and V4 are connected to AC sources. At resonance, what will happen? So at resonance, the net voltage V4 will be equal to square root of V1 square plus V2 minus V3 whole square. This is why V2 is now V2 is the voltage across the inductor, V3 is the voltage across the capacitor, V1 is voltage across the resistor, and V4 is the net voltage across the source. net voltage of the source. So at resonance, what will happen? VL that will be equal to this. This what V2 will be equal to V3. This will become 0. So therefore V4 will be equal to V. V4 will be equal to V1 and V2 will be equal to V3. V2 that is equal to V3. So option the reading in V2 will be equal to the reading in option D is the correct answer. Then it is told a resistor of 500 ohm, inductance of 0.5 Henry are in series with an AC which is given by D equal to 100 root 2 sine 1000 t. Resistor is there and an inductor is there. 0.5 Henry is the inductor, inductance, resistance is 500 ohm. That is series. In the power factor of this combination, power factor cos phi that is given as R by Z. So here Z that is equal to the root of R square plus XL square is equal to square root of R square plus omega square L square. Omega that is here, omega is 1000 radian per second. It's omega L that will be equal to 500. Therefore Z that will be equal to square root of 500 square plus 500. So omega L is 500 ohm is XL, is the inductive reactance. So this is equal to 500 root 2. So therefore the power factor of this combination is cos phi equal to R. R is 500 by Z. Z is 500. That will be equal to 1 by. Option A is the correct answer. I hope all of you have understood the solutions of all these 13 questions. So here we shall end the first part of this video on alternating current. So any doubts if you are having, then please write that in the comments section, and install our Sapience education application where we shall upload some important previous year KCET questions on every chapter. Thank you everyone.